Giant ionic structures. First up are giant ionic structures. These are made from positive and negative ions arranged in a giant three-dimensional lattice. The ions are held together by strong electrostatic forces of attraction between opposite charges. A common example is sodium chloride, NaCl. Because these attractions are so strong, giant ionic compounds have several important properties. They have high melting and boiling points because lots of energy is needed to separate the ions. They are hard, but also brittle. If you hit an ionic crystal, layers shift so ions with the same charge line up and repel each other, causing the crystal to shatter. Another important property is electrical conductivity. Solid ionic compounds cannot conduct electricity because the ions are fixed in place. However, when molten or dissolved in water, the ions are free to move, so they can conduct electricity. Giant covalent structures. Next are giant covalent structures. Instead of ions, these are made from atoms joined together by strong covalent bonds in a giant network. There are no individual molecules. The three GCSE examples are diamond, graphite, and graphene. Let's look at diamond first. Every carbon atom forms 4 covalent bonds. This creates an incredibly strong structure. As a result, diamond has a very high melting point, is extremely hard, does not conduct electricity because there are no free electrons. Graphite is different. Each carbon atom forms 3 covalent bonds, creating layers. These layers can slide over one another, making graphite soft and slippery. Graphite also has 1 delocalized electron per carbon atom, allowing it to conduct electricity. Graphene is just 1 layer of graphite. It is incredibly strong, very light, and an excellent conductor of electricity and heat. Simple molecular structures. Simple molecular substances are very different. Examples include hydrogen, oxygen, water, carbon dioxide. Within each molecule, there are strong covalent bonds. However, the forces between molecules are weak intermolecular forces. Because these forces are weak, simple molecular substances usually have low melting and boiling points, do not conduct electricity, are often gases or liquids at room temperature or soft solids. Remember this exam tip: strong bonds inside molecules, weak forces between molecules. Properties of substances. Now let's explain why different substances have different properties. The properties of a substance depend on its structure, its bonding, and the forces between particles. Let's compare them. Giant ionic high melting and boiling points. Conduct electricity only when molten or dissolved. Hard but brittle, often soluble in water. Giant covalent. Very high melting and boiling points. Usually do not conduct electricity except graphite and graphene. Very hard, except graphite because its layers can slide, generally insoluble in water. Metallic structures. Metals have positive ions surrounded by a sea of delocalized electrons. These free electrons explain why metals conduct electricity and heat. Layers of atoms can slide past each other without breaking the metallic bonds. This makes metals malleable, ductile, strong, good conductors. Simple molecular substances have low melting and boiling points, poor electrical conductivity, weak intermolecular forces, often exist as gases or liquids. Always remember, structure determines properties. Nanoparticles. Finally, let's look at nanoparticles. Nanoparticles are extremely small particles, measuring between 1 and 100 nanometers. Their tiny size gives them a very large surface area to volume ratio. This means more atoms are exposed on the surface. As a result, nanoparticles are often much more reactive than larger particles made from the same material. Uses. Nanoparticles have many useful applications. They are used as catalysts to speed up reactions, in medicine for targeted drug delivery, in cosmetics such as sunscreens, in electronics to make smaller and faster devices. Advantages. Advantages include faster chemical reactions, improved medicines, stronger and lighter materials, better performance in many products. Disadvantages. However, scientists are still researching their long-term effects. Because nanoparticles are so small, they may enter the body easily, affect living organisms, cause environmental problems. This is why careful testing is important before new nanoparticles are widely used.